Okay, so I've just started playing this game, Cubism, and I figured I'd make a little tutorial on how to solve some of the harder problems. So you can see I've gone through and done some of the easy ones. And then I've done a few of the expert ones. I've done this one, which was master level. And I guess for the hard ones, or the normal ones, you can kind of just play around with it and kind of see how to solve it. Whereas as you start to get to expert or master problems, you kind of need more of a formulaic approach. And so I'll walk you through how I solved this one. So don't look at the solution, I'll take this apart. So we've got these pieces and we have to get them into this cube. So what I usually do is look for the most awkward pieces and I try them first because they limit the number of possibilities. If I put an easy piece in like this, then this can still go anywhere. Whereas if I put in this piece, then that really limits where some of these other pieces can go. So these two pieces kind of look like they fit together and they look pretty big. I mean, most of these are kind of two-dimensional. And so there's a lot more possibilities with them, whereas since these are three-dimensional, they have a lot more restrictions. So I'll probably try to place these first. And I can also see there's not very many possibilities for these 3D plus symbols. And in fact, the only way they can fit together is like that. And so I already know that they have to kind of go like this. And then the other difficult piece is this piece, because it's kind of big and doesn't fit together that well with other pieces. I mean, maybe it could interlink nicely like that with a few of these pieces. But I think these three are the best to start with and to really limit down the possibilities. Another thing to notice is that can't go like that. Also, when we place, like if we try putting this in the middle, then how can we fit the pluses in? Seems difficult. And in fact, if we put the pluses in the middle, we can see there's a cube in the middle. And because of this little square here, we know that we'll never be able to fit this in the middle. Like that's going over the edge. We can't go any further because this piece is hitting. And so what that tells us is this piece has to go on the edge of the cube, like here. And so that basically tells us this has to go on a side. Oh, what's going on here? This has to go on a side. And it can go on any side. We could always rotate the cube. So I'm just going to put it at the bottom side because I like to start from the bottom and build my way up because then I can see a bit more of what's happening. So what are the different possibilities? It can go here or here. I mean, it could go here, but then if we rotate it, we just have what we had before. So are these the only two options? Have a think about it. And you also notice it's kind of like a three shape or a backwards three. The other option is we can go like this. And that does make a difference due to symmetry. Some of these pieces aren't symmetrical. If every single piece was symmetrical, then it probably wouldn't matter. There'd only be two possibilities. Because if we got a solution going one way, we could flip everything symmetrically. We'd have a solution going the other way, but that's not the case. For example, this piece here can fit nicely like that. But if we flip this, and then we try to put this piece here, it doesn't fit nicely, you can see. Yeah. So I think this is a good starting point. So we're going to try this three shape here, and then we'll try it here, and we'll try it here, and then we'll try it here. And we'll just try to eliminate possibilities. Okay. And now we try these pieces. So if it's here, the only place this can go is here, because we know that this has to touch the bottom. I mean, can't fit there or there, right, obviously. So how can we eliminate this as a possibility? So probably the most awkward place to fit is this here. So, you know, that can't go in. This can't go in. This can't go in. And so nothing can actually go in there. So we've already shown that, okay, we know that this green piece can't go there. So the next thing to try is there, okay? Now, this is 3 places it can go. But it can't go here, because there's a square here. So that means this piece has to go here or here. Now this is kind of interesting, having this shape here, because there's not very many things that can fit into here. We can have something from below or something from here, but actually, remember we need this plus here. So that means this shape can only be filled by this bit here or this bit here. So, I mean, that can fit in, right? So maybe that's an option. And this can fit in. So maybe they're both options. So, okay, I thought that would be able to eliminate this just by doing that, but those two fit. So this square looks kind of hard to fill. So what can go here? Like this can't go there. Can go like this. Yes, can go like that. But then this looks pretty hard to fill. So that's impossible. None of these pieces can go here. So it only leaves this option. If we go like that, then nothing can go here. The only other option is for this to go here, like that. And what can go here? I guess this can go there. That's the only option. I mean, this pieces are the same, so I could have gone there too, but like, oops. I mean, could anything else have gone here? This piece can't. Okay, so let's try go with that. And we also said, but that means this can no longer go there, which means this is the only option for here. Okay. And now, what can go here? This is the only option. Okay. Okay, so I've accidentally solved it. I wasn't meaning to solve it. I was trying to show how to eliminate possibilities, but there you go. But if we wind it, so what I kind of do is I remember where I was. So these are the 3 pieces that I was doing first. So I kind of unwind it, and so we ended up having this as a solution. How could I have known that it wasn't like this? So I flip 3. Let's see. So that has to go there. And then, yeah, the only 2 things that can go here is this. This bit's not possible to fiddle in. Right, nothing can go there. So that can't go there. And that can't go there because of that. So we've eliminated that as an option. So we know that the 3 can't go like that. We know that can't go there. The only other option is this. So how do we know if this is a possibility, maybe we could have tried solving it this way. How can we eliminate that? So for this square, the only way this can go is like that. And then we need this here. So then that doesn't seem possible. So actually that can go with that. So the only thing that can go in here is this, and that's not possible. So this bit doesn't go there. So the only other thing that can go here is this one. And this isn't possible. The only other option is that. Nothing can go here. So we've eliminated this possibility. We eliminated that. And so and we eliminated that. And we eliminated this, I think. How did we eliminate that? So, yeah, there's nothing that could go there. How else could we have done this? So the solution was like that. We could have also tried, well, we couldn't have tried that. Could we have tried that? I think this is not possible because of this. Yeah, maybe this could be possible. How can we eliminate this as a possibility? This isn't possible because this has to go here. So yeah, nothing can go here. And then, so that had to go like that. And the solution was here. How did we know? And it wasn't there. The only other option was this. So how could we have eliminated this possibility? Let's see. So this has to go here. And yeah, and then I guess what can go here? Can this go here? Yep, but then nothing can go in here. So then the only thing that can go here is this. And nothing can go there, I don't think. I don't know. And like that, and then nothing can go here. Yeah. So the only option was to do this. And then we had to have this here. And so then the only option for this, we couldn't put this here. And we could. What was the reason for having to put it? We had to put this there though. So how did we eliminate this possibility? Can't remember what I did before. But yeah, this red piece doesn't go there. I'm not sure why. That can't go there. Yeah, I guess that can't go there. So the only thing that can go here is this. But then this isn't possible. So yeah, that's why this can't go there. So then it has to go there. And then from here, you can pretty much solve it. There's not many possibilities left. That can't go there. I mean, this looks kind of plausible. But there you go. Anyway, that's that. And I guess one thing that helps from computer science is often when you're doing software, you use something called a stack or a heap. But if we think of this in terms of a stack, it's like we're trying all possibilities for this piece, and then we're trying all possibilities for this piece with that first possibility, and then so on. So we're basically doing a brute force. And then if this doesn't work, then we try moving this. And then we place this. If that doesn't work, we move this. If that doesn't work, then we try all possibilities for this. So we know that this is wrong. So then we move that to there. And then we try all possibilities of this, and then all possibilities of that. So it's basically, so I guess the strategy is to find the most awkward pieces first and just try, find combinations of pieces that really limit the number of possibilities, and then try to eliminate different pathways. So I guess it's kind of like a branch and bound algorithm. But sometimes if you use, you'll see that some pathways are more likely than others. And so some pathways have more possibilities, but often I like to eliminate, sometimes I like to try the least likely options first, just to make sure that, because they're the easiest to prove that they're not the right pathway to take. And that means you have to memorize less state in your mind, kind of thing. Whereas if you go for the best option first, then there'll be so many ways that the pieces can fit together that you might be second guessing yourself. Whereas if you eliminate all possibilities and you know this piece has to go here, for example, and you know this piece has to go here, then you can kind of spend more time thinking about what matters and what's important. But yeah, anyway, so that's Cubism. Yeah, hope you enjoyed this.